Hello, my name is Aaron, and I'm here to do the presentation for the engagement bot. The engagement bot will be activated by a robot operator, which will have sensors that are detachable to put on the front and the back door. My engagement bot will be for the back door sensor. When the dog has moved through the doggy door of the back door and is in the backyard, the robot operator will pick that up and send out a signal to the engagement bot, which, when deactivated, will be in a storage unit on the back patio. This storage unit will be like a mini locker. Upon activation, the locker itself will open up as the robot is turned on, and then the robot will roll out and begin using its own AI capabilities to just play with the dog. There are three primary forms of play that we have taken into account. The first is merely petting. When the dog is just chilling, the robot will come up using its humanoid arms and give the dog pets. When the dog is playing with a toy, the robot will come up and try to take the toy with its robot arms. If the dog refuses to let go, then it will engage in tug-of-war with the dog. If the dog does let go, then it will engage in fetch with the dog. If it finds a toy on the ground, or the dog brings it a toy and drops it on the ground, it will also pick up the toy from the ground and play fetch.
Hi, my name's John, and I'm going to be presenting the Healthy Pet Robot, which is our automatic dog feeder and water monitoring system. Healthy Pet's designed to make nutrition for your dog easy and reliable when the owner's away. The system works inside a small housing that holds a food hopper, a water tank, and 2 bowls on scales. These scales measure exactly how much food and water the dog has, so the device always knows when the bowls need refilling. On the back of the unit, there are 2 rotary dials that are controlled by the user. One dial lets the user set the portion size as small, medium, or large, and the other dial sets the feeding schedule, which is based on a 12-hour cycle. This allows the user to control Healthy Pet without any complicated screens or unnecessary interfaces. Inside the robot, the servo motor controls the food dispenser. When it's time to feed the dog, the servo rotates for a set amount of time set by the user for the portion, and for the water, a small DC motorized pump refills the bowl anytime the scale detects that the weight has dropped below the minimum. Because the robot constantly measures the food and water levels, it can confirm that the food was actually eaten and also track how much the dog consumes daily. The algorithm that powers Healthy Pet is pretty simple and straightforward. So when the device first turns on, it reads the 2 dial settings selected by the user, and once the settings are read in, the robot enters a continuous loop. In the loop, it checks the water bowl first. So if the bowl is low, the pump turns on and fills it until the target weight is reached. At the same time, the system keeps track of the current time of day. So when the scheduled feeding time comes, the servo motor activates and releases the food. After feeding or refilling, the system goes right back to monitoring. So this repeats all day, and it makes sure the dog always has the right amount of food and clean water.
Hello, I am Corbin. I'm the designer for Pawtrax. This here is going to be a dog walking companion. If we look at our diagram on the left, the exterior of it, it features the dog leash, which the dog owner will manually connect to the dog collar. Just below that we have 2 sensors. These are to detect obstacles both near and further away, such as vehicles and potholes. Our red ring, that is going to be a LED light. The LED light will flash when the Pawtrax is in motion, and then it will be a steady red when it is stationary, and that is just to alert bystanders and vehicle operators of the presence of the robot and the dog itself. And then we do have tracked wheels on it as well. That is going to help with our obstacle maneuverability and our traction. If we look over at our circuit is going to compile this motor drive here. We have 2 DC motors that are going to operate the left and right tracks, and then we have 2 sensors for our obstacles and a pixel ring that is programmed again for flashing lights when it is motion and a steady red light when it is stationary.